Problem 1 asks us to compute the value of the correlation coefficient. Now the correlation coefficient gives us some information about the strength of this linear relationship between these two variables. So it kind of works off of this idea of a scatter plot. So if I plotted my data, I plotted points, I had a ton of points, and I plotted them on a scatter plot, kind of like this. This relationship here, this linear relationship, is going to be a positive one. Because if I try to draw a line that was that best approximated all of this data, that line would have a positive slope. So it's positively correlated. Now the strength of that correlation, so let's compare this to this here. See, now these two sets are both positively correlated, but this data set is more closely bunched together, whereas this is more widely spread. So this would have a stronger positive correlation than this. Negative correlation would be if I try to draw a line that approximated this relationship, it would be tilting downward and have a negative slope. The correlation coefficient, we use R to abbreviate that. It goes between -1 and 1. -1 means it's a perfectly negative relationship, in effect, a line that has a slope of -1. R goes from -1 all the way up to +1. +1 is a perfectly positively correlated relationship. So that's kind of the span of R. It goes between -1 and 1. 0 means there's no correlation at all between the two variables. So if we look at our formula sheet, we're in chapter 10. They have a formula here for the correlation coefficient. It's a pretty involved formula, as you can see. I will show the formula one time, and then I'll show how to do this using the calculator. I think the calculator is probably a more preferred means of getting to the solution for especially the stuff in chapter 10. You can look at these formula and see that there's a lot involved here. So let me rewrite the formula, and then we'll use it to try to figure out R. Where am I? R. Okay. So R equals, let me look back at the formula. I forgot already. Yeah. N times the sum of the xy's minus sum of x times the sum of y over the square root of n times, let's see, sum of the x squareds minus the sum of x squared. Okay. The sum of the x squareds minus the sum of x squared, right? And then I'm multiplying that. Let's close that parentheses, open another one. N times the sum of the y squareds minus the sum of y squared. There's a lot of stuff in there. A whole lot of stuff in there. So essentially what we're doing is we're finding, so I'm going to rewrite these values in a vertical format. So I have x, I have y. So I have 50, 44, 41, 52, 40. Those are my x values. My y values, 158, 150, 134, 171, 149. So I need the sum of the x's and I need the sum of the y's, right? I need that. So I'm gonna, this last row here is gonna be dedicated to the sums. I'll do that after. I need x times y because I'm gonna sum that. I need x squared. I need y squared. I need to find all of these values. And then, since these are all sums, I need to sum the products. I need to sum the x's, sum the y's. I need to sum the x squareds. I need to sum the y squareds. So it's a lot that we have to do here. And I'm going to use my trusty graphing calculator to do these calculations. And I'll show you a quicker way to do them as well in your calculator. So 50, I'll type them in, plus 44, plus 41, plus 52, plus 40. That's 227. So these are the sums for my y's. There's a more efficient way to do this. I will show that. 158 plus 150 plus 134 plus 171 plus 149. 762. So let's add the squares. So I have 50 squared. I really don't want to multiply these individually, so I'm just going to start adding them already. Plus 44 squared plus 41 squared plus 52 squared plus 40 squared. And I'm going out of order, it seems, right? So that's the sum of the x squareds. 10421. Okay, I'm going to do the same for the y's. So 158 squared plus 150 squared plus 134 squared plus 171 squared plus 149 squared. 116862. 116862. Okay. Now x times y. I need to sum those as well. So let's say 50 times 158 plus 44 times 150 plus 41 times 134 plus 52 times 171 plus 40 times 149. All right, let's make sure I got that. X times y plus x times y plus x times y plus x times y plus x times y. Okay. That sum is 34846. Okay, let me look at that. 34846. Okay, so I have all of my sums. Now I'm going to put them into this formula to find R. All right, let's see. So n is the number of pairs, right? 1, 2, 3, 4, 5. N is 5. So I've got 5 times the sum of the xy's. So that's 34846 minus the sum of x, 227, times the sum of y, 762, divided by the square root of, okay, let's see. So I have n again, 5 times the sum of the x squareds, which is 10421, minus the sum of x, which is 227 squared. It's in its own parentheses. And then here I have, where's 227? There we go. 5 times the sum of the y squareds, 116862. And you can see if you put one of these numbers in wrong, you're in trouble, right? Minus 762 squared. And I hope I didn't put any number in incorrectly, because then I'll be in trouble. Okay, I'm going to attempt to put this all in my calculator now. Okay, let's move it over here. So let's put these in and see what happens. So I'm going to put parentheses around my numerator. So I've got 5 times 34846 minus, so let's just put these in no, I don't need parentheses, minus 227 times 762. That is my numerator. Okay, now we're dividing. Divided by the square root. Open parentheses. I need to open another one, because here I'm saying 5 times 10421 minus 227 squared. I'm going to close that parenthesis, so that closes this first part. And then I open another one, multiplying here. So I've got 5 times 116862 minus 762 squared. Close that, then close the square root. Okay, I'm going to click this button, make sure I hope everything's in there correctly. Let's look. Numerator, 5 times 34846 minus 227 times 762 divided by the square root of 5 times 10421 minus 227 squared, then 5 times 116862 minus 762 squared. Enter. So our correlation coefficient is 0.864. And that's a pretty strong positive correlation. It's pretty close to 1. So this data here is very closely correlated positively in a positive direction. Now I'm going to show this. So this is the only time I'm doing this process, because I don't want to do this again. And I suspect you might not want to do this again. So I'll try to do this in the calculator. How to compute the value of the correlation coefficient using your calculator. Okay, here we go. So I'm going to hit stat, because I'm entering some statistics, and edit. So edit these lists. L1, I'm going to put my X values. L2, I'll put my Y values. All right, so 50, 44, 41, 52, 40. And then L2, I'm putting my Y values, 158, 150, 134, 171, 149. So my X values are in, my Y values are in. I go back to stat, because now we're going to calculate something. This is all within that chapter on linear regression. So what we're calculating is a linear regression, linreg. I go down, I hit enter. Linreg, linear regression with AX plus B. It's the equation of the line. And I hit enter, and I get A and B. I get the slope and the y-intercept of this line, but there's no R here. There's no correlation coefficient. There's no R squared, which we'll talk about in the videos down below. If this happens to you, it's because you didn't turn the diagnostics on in the calculator. You have to turn the diagnostics on in order to compute the correlation coefficient. So in order to do that, I'm going to clear out of here. We have to go to the catalog. That's second and the 0 key. The word catalog is right there. It's kind of hard to see. But second catalog. You can either go scroll down to the D's or hit this key here for, you see the D is in green. That's the alpha. I can hit that for D. Scroll down to diagnostic on. I need to turn that on in order to compute the correlation coefficient with this calculator. So diagnostic on, hit enter. It says done. That's all it does. It says it's on. Go back to stat. The data's still in there, right? The data's still in there. Go back to stat. Go to calculate. Linear regression. And when I do it now it gives me this R squared, and it gives me R, the correlation coefficient, which we found through all of these calculations here. The calculator will also compute it pretty quickly. So that's how I suggest you calculate the correlation coefficient if it shows up on this exam.